So, there are three computing paradigms which is followed in subcomputing. One is fuzzy logic, another is genetic algorithm, and the third is artificial neural network. So, today we will introduce the genetic algorithm, the computing paradigm for subcomputing. Now, genetic algorithm is basically used for solving optimization problem. Now, we know exactly what is an optimization problem. So, the optimization problem essentially solving to find the optimum value, that means find the minimum or maximum value. As an example, say suppose this is the value for which the different so suppose f x is a function which varies with x. So, if it is x in this direction, then f x, this is the f x. Now, so this concept, so suppose the value of f x varies with x using this form, it is like this. Now, so this means the value of f x varies with x and it takes the form like this, and we can say that x as it varies, then it has many values. So, here basically the for some x the value f x is highest, it is the maximum, it is another maximum, or so on. Similarly, minimum, these are minimum, this one. So, it basically says that how the f x varies with x, and if it is like this, and if you have to find which is the maximum value for which, or what is the maximum value of f x, or for which values of x it is the maximum. So, that can be obtained, and if we have to search it, then it is called the searching for an optimum result. And so far the searching for an optimum result is concerned, it has many what is called the values actually. Here these are the value is a highest value, is a peak. All peak are basically some values, they are called maxima. Similarly, all this is the lowest values, the valley, it is called the minima. Now, out of these so many maximas, there are some values, it is called the global maxima. If we say that this is the maximum of all the maxima values. Similarly, it is a local maxima, local minima, if it is minimum of all the minima values there. So, the concept is local maxima or local minima, and then global maxima or global minima. So, finding an optimum value, that means a minimum which is global maxima or global minima, is called the solving for optimization problem. Now, we will discuss about the GA, the genetic algorithm, which basically gives us a unique and fantastic way to search for all optimum values, that means either minima or maxima. Before going to discuss about the genetic algorithm, we will just discuss about how mathematically the optimization problem is defined. If suppose x 1, x 2 x n are the input parameter is given to us, and we have to find the function which is defined by f and which is discussed with this in terms of these are the input parameters. That means, the value of f is decided by the value of all these parameters x 1, x 2 x n. So, this is a function, we call this function as a objective function. So, this function is called objective function. Objective function. Now, we have to find either say optimum value, optimum means either a minimum value or maximum value for a given set of values of these x 1, x 2 x n. Then this is called the optimized value. So, this optimized value can be either minimized if we have to find the minimum values, or we have to either find maximize if we have to value the maximization value. So, objective function always in terms of either minimization or maximization, and this basically defined by means of an objective function which takes like this x n. Now, this functions, this optimization in fact subject to certain constants. So, if it is minimized, and constant may be another function g I x 1 x 2 dot dot same set of parameters. Now, this may be equals to 0, where there may be one or more constant. So, this I equals to 1 to m. So, if m constants are there. So, this basically this is the objective function, it is like this, and this is basically the constant, usually we denote as subject to. So, there may be g 1, g 2 and dot dot g m constant. So, here the finding an optimum value, that means finding some values of the input parameters, so that this function return the optimum value and it should satisfy all these constant. Now, this problem is no more a trivial problem in fact, and this problem cannot be solved in normal time. That is why we need some pragmatic approach like say soft computing to solve the optimization problem. That means, we have to find the values of input parameters for which a function f should return an optimum value, minimum value or maximum value, and at the same time it should satisfy such constants, number of constants. So, this program is no more a simple program. So, traditionally there are many methods are available and to solve this kind of optimization problem, but they have their own limitation. Actually, the traditional optimization methods are in fact computationally expensive. That means, they cannot be applied to solve some optimization problem in real time. It may take 1 month to solve some problem like, and all the traditional optimization methods are usually not suitable for a discrete objective function, and so they are not suitable for discontinuous objective function. There are some functions which have certain value in some ranges. So, is a discontinuity if they are in the objective function, those methods fails, and as it is a time consuming what is called the task finding an optimum value. So, usually we advise to follow parallel computing, but the parallel computing may not be implementable, may not be realized using traditional optimization. So, we need something which basically suitable for parallel computing, and it is observed that traditional optimization approaches are not good enough to deal with the discrete values of the input parameters. So, if the input parameters are having discrete values, then the existing optimization technique cannot solve them. And another limitation of the existing approaches is that they are not necessarily adaptive. Adaptive in the sense that the same algorithm that you have developed, if we have to apply to m number of parameters instead of n, where n may be greater than m or less than f. That means, if the input parameter increases, then you have to rewrite the method, the program totally differently. If the say input parameter type is different, earlier it was for integer, now we have to see it in real time. So, then it cannot be. So, there are actually they are not adaptive. Adaptive means, if the environment changes, input changes, the input parameter type changes, then the traditional approach is not easy to adapt them. So, we need some new method which basically address all these limitations, and we will see the evolutionary algorithm. It is an alternative approaches to the traditional optimization approaches that can solve and then address all these problem. So, genetic algorithm is basically one special type of evolutionary algorithms, Now, so far the evolutionary algorithms are concerned, how they are different than the traditional approach. So, they are different in terms of they are the way they solve the problem. In fact, the evolutionary algorithms, they follow few concepts, and the concept is called they follow certain biological and physical behaviors which is around our globe, in our world. So, genetic algorithm which we are going to discuss is basically follow the concept of genetics and evolution. Genetics is a well known concept in biology, and evolution is also an well known concept in biology. So, these are biological concepts. So, genetics and evolution is followed to solve the optimization problem, then this is called the genetic algorithm, and popularly it is abbreviated as GA. Now, the way the ant they collect the food or they invite other fellows to a particular food source, it has been followed to solve optimization problem, and this is called ant colony optimization. So, it is also some sort of behavior of ant which has been followed, and their behavior is basically adapted into to solve optimization problem. It is called the ant colony optimization, called SCO. Now, like there are how our nervous system work. If we follow the concept, then and if we apply it, then we can solve many problem. This is called the artificial neural network or ANN. So, these are the classes belong to the biological behaviors. There are some physical behaviors, the matters how they work. Now, annealing process is the one process which is used to prepare the metals, and if we follow the annealing process to solve a type of optimization problem or optimization problem, then it is called the simulated annealing. It is abbreviated as SA. Now, particle how they swarm in a stream or flow, the same concept can be followed to solve another optimization type of problem. It is called the particle swarming optimization problem or PSO. We have learned about fuzzy logic, how fuzzy logic can be used to learn. So, this is also another physical behavior. So, all these concepts are basically the concept which is followed in evolutionary algorithms. Now, in this lecture we will basically focus on specific evolutionary algorithm. It is called the genetic algorithm. As I told you, genetic algorithm like ant colony optimization, particle swarm optimization is another type of evolutionary algorithm, and it follows the two important biological processes called the genetics and evolution. And particularly it has been observed that genetic algorithm is tremendously successful in case of solving the problem which are basically called combinatorial optimization problem. That means, the problems which cannot be solved in real time. It is also called NP-hard problem, or we can say the traditional methods if we apply to solve this kind of problem, that means NP-hard problems, it is computationally very expensive and cannot be completed in real time. So, it is the problem, and then genetic algorithm have been applied to solve this kind of problem, and we can see the result in real time. And more significantly, the genetic algorithm is best suitable for those kind of problem for which any specific mathematical model or a suitable algorithm is possible to define how to solve the problem. If we are not have that specific algorithm or steps to solve the problem, then we can apply the genetic algorithm to solve this kind of problem. So, the problem which is very difficult to model mathematically or specific algorithm is available, then we can apply the genetic algorithm to solve this kind of problem. And if a problem involves a large number of parameters, the parameters may be discrete or may be continuous or anything, then the traditional approach is very difficult to use it, but genetic algorithm can be used to solve this kind of problem efficiently and effectively. So, this is the idea, this is the history behind the genetic algorithm and which we can follow it. Now, I just want to start with a little background about genetic algorithm. So, it is as early as in 1965 Professor John Hallan from Michigan University, he first proposed the concept of genetic algorithm in 1965, although he has proposed the idea, but ultimately it was acceptable to the research community much later in around 1975. In fact, the two pioneer who work to make the GA most successful, they are the two revolutionary people. One is called the Gregor Johann Mendel and Charles Darwin. Gregor Johann Mendel in 1865 he proposed one revolutionary concept called the genetics, and around 10 years later Charles Darwin, who proposed the concept, it is called the evolution, and that these two concepts are merged together to solve the optimization problem, which become the true origin of the genetic algorithms. So, in order to learn the genetic algorithm, it is better that we should learn about the two things, the genetics and evolution first. Now, as I told you, Gregor Johann Mendel is the forefather of the concept of genetics, and genetics is an well known things, and you know genetics comes from the concept called gene, and gene is basically a fundamental things in our life, and it basically say that our body is consist of a large number of cells, living cells, and each cell is basically consist of what is called the one essential part in the cell, it is called the chromosome. And if we go into details about the chromosome, in fact, there is a spiral helix form and they are called the genes, and these genes are basically the characteristics of a particular cell. So, or in other words, a chromosome decides a particular type, whether it belongs to monkey or it belongs to man or it belongs to cow. So, it is also observed that chromosome in terms of number, the different species that we are having have the unique number of chromosome. For example, mosquito has number of chromosome 6, human has 46, 23 pairs, and goldfish 94, out of which goldfish is the one element which is having the largest chromosome. Now, so chromosome is one important things that is there, and in fact, this chromosome also plays an important role in our genetic algorithm. We will learn it exactly how the chromosome is synonymous to genetic algorithm. First, let us see exactly how the chromosome actually works it. Now, see chromosome basically is a code, it is called the genetic code also, and we know that every individual has its own characteristics, own features, own specification. This is because his genetic code is unique and it is completely different from any other individuals around. So, a genetic code is basically looks like a spiral helix. It is basically a protein substance, and this protein is called DNA, deoxyribonucleic acid, and a typical look of the protein DNA is look like this. So, this is a DNA structure, and this DNA has its own unique structure for a particular individual, and that is why we say that it is unique. And if we can represent this DNA code, then we can basically identify the person in fact. So, that is why this DNA code is used as a biometric trait. That means, by this DNA we can identify a person uniquely. Now, so this is the concept of DNA, and then this concept is basically is also important in the reproduction. The reproduction, as you know, so the two what is called the half cells, they are called haploid. Two half cells from the two opposite sex, male and female, obtained, and then when they merged, they form the diploid, and then this diploid is basically form a cell. So, here very important thing is that haploid is basically one part which has the half number of chromosomes, and this is the another half number of chromosomes, and when they merge together they form the diploid, which basically contain the full number of chromosomes. So, here is basically the division, after that unification, and then it produced another unique what is called the unique identity or unique elements. So, this is the concept that is followed in reproduction, and So this is the part of the life and we just follow the reproduction, but behind this reproduction there is one important thing that we have learned about, that from 2 haploid we got a diploid, and here is the idea about. So, this is the one chromosome from one haploid, another chromosome from another haploid, and there is one point, it is called the kinetochore point. Now, they basically combine this kinetochore point, and then so from one element here and another element here, and then if we constrain another element which is basically one part of here and another part here. So, basically it basically gives the one chromosome to diploid, similarly another chromosome to diploid. Now, here one thing you can note, if we take one part here and one part here. So, the new chromosome that we get, so it has the two called a mixture of chromosomes, and that mixture of chromosomes basically is able to produce a new elements or new identity. Now, so this is the fundamental thing that is followed there. If we follow this kinetochore point in different position, then we can have the infinite number of different possibilities of having the unique identity. So, in this sense the reproduction allows or reproduction produces a unique element every time it reproduces from 2 chromosomes to another chromosomes or 2 haploids to another diploid. So, this is the idea that is follows there, and this concept in genetics is called the crossing over, and we will follow it exactly the concept of chromosome as it is there in genetics. Similarly, the crossing over or simply it is called the crossover is also an important what is called the philosophy that is followed in optimization technique. Now, so this is the genetics which basically Gregor Johann Mendel proposed first, then how reproduces, and every reproduction produce the unique element. Next, evolution, it is basically improvement from one level to another. So, regarding this evolution, the Charles Darwin is the forefather of this work. He proposes 4 concepts. So far the evolution is concerned, the 4 concepts are basically heredity, diversity, selection and ranking. So, according to this Charles Darwin, heredity, it is basically called information propagation. Information propagation means that an offspring has many of its characteristics of its parent, and therefore, the property or characteristics from its parent is basically passes through its offspring, offspring means children. So, this is called the heredity, that means we inherit something from our parents. So, that is the concept heredity. And population diversity, so Charles Darwin termed it as a diversity only. So, it is basically called the variation in characteristics in the next generation. So, if we see the different generation, no 2 generation we can obtain which have the same identity always, it have at least some minor difference maybe, but differences are there. Next premises is called the selection, that is very important, and this selection Charles Darwin termed is that survival for existence. So, basically out of many offspring, only a small percentage of the offspring is basically able to survive in to adulthood, and other basically go to dies to exist, they cannot sustain much more. So, that is a selection, and our world is basically follow this selection procedure, and that selection is basically called the survival of the best. So, Darwin called it a survival of the best, that means only those offspring they survive depends on their inherited characteristics. So, it is based on the ranking. So, these are the 4 things, 4 premises rather which is followed there in so far the evolution is concerned. So, evolution will be carried forward, and Charles Darwin shows that these are the 4 primary things by which the evolution can takes place, and evolution is followed there, and this evolution also Charles Darwin called the natural selection initially. So, but we will term it as evolution, and we will see exactly how these 2 concepts are followed in genetic algorithm, and then genetic algorithm has been proposed. Now, other than this genetic algorithm concepts, there is another is called the mutation. We will discuss about the mutation. The mutation means all of a sudden there are some changes. So, 2 parents, those are the fair skin, all of a sudden their offspring may be black also. So, it is due to the mutation. All of a sudden there are some changes, that means there are certain drastic differences in their chromosome property, and that is the mutation. So, mutation is also one part of our natural what is called the process, natural generation production or genetics. Now, so this concept is basically followed there, and we will learn about that how the concept of biological process, namely genetics and evolution, is followed there. I just briefly summarize the concept that we have learned so far. So, if we have a population which is the population initially, and then from this population we follow the mating pool. Mating pool means we just simply see that who can be fitted for mating and others. So, there is a mating selection like marriage or whatever it is there. So, after the mating selection is there, then it starts as a mating, and it basically, so genetics is followed there. So, that is the mating, and then from the mating we follow whatever the crossover mechanism or crossing over that thing, and they produce the reproduction. So, this reproduction produce the new offspring, and new offspring altogether produce the new generation. So, eventually the idea is that from the current population, following the reproduction procedure, we obtain the new population, and here in between there are genetics and evolution involved. Now, these are the concept that is followed there, and in genetic algorithms we are basically using the same concept. So, I can start with the genetic algorithm concept. It is basically is an algorithm, and this algorithm is a population based and is a probabilistic search. Probabilistic search means the mating and reproduction is a probabilistic random, and then optimization, it is basically selecting the best candidate from there, and which works based on the concept of genetics and then evolution. So, this is the concept of genetic algorithm. So, the fundamental thing it is there, the genetic algorithm is basically is a population based probabilistic search, that is important. Now, we will learn about how the population based probabilistic search can be achieved and using the genetics and then the concept of evolution. So, this is the our objective, study objective, and we will see exactly how this can be done. Now, quickly I will start with first the architecture of genetic algorithm. So, this is basically the flow chart of genetic algorithm. So, we start with any population. So, we can say that initial population, randomly we select some population actually, and then there is a concept called the converge. That means, if we say there is no improvement in the next population, then we can say that stop it here, no more progress. But if we say there is some possibility of progressing, so then we can go, and then selection, it basically out of this population select the best, and those best basically responsible for reproduction, it generates the next population. So, it will go there, and again start that whether next population is converge. Converge means we can achieve our goal or not, that means complete or not. So, this way this algorithm is basically a process, a continuous or iterative process which run for long until we can come to the converge. So, converge means in the sense that we can search the optimum result. So, that is the converge. Now, here many things are hidden. So, how this population is related to our problem solving, and how the selection and reproduction can be realized, so that from one population the another population can be obtained. So, the another population means it is basically towards the better solution, and these are the process, selection and reproduction is basically is a fundamental block for probabilistic searching. So, we will discuss about this concept in details in the next class. Okay, fine. So, this is the basic framework of the genetic algorithm, and based on this basic framework there are many other frameworks also have been proposed. All these things we will discuss in the next class. Thank you.